A warm welcome to everyone. This is Team Deepsea Decoders. Our problem statement proposes the development of an AI powered conversational interface for Argo flow data that enables users to query, explore, and visualize oceanographic information using natural language queries. Ocean data is incredibly rich, yet most of it remains difficult to access. The data is scattered across formats, stored in complex scientific files, and requires specialized software just to open. Researchers, policymakers, and even students often struggle to query or visualize this information without deep technical expertise. Argo floats are one of the most powerful sources of ocean intelligence. They generate millions of netcdf files with temperature, salinity, and biogeochemical data from across the globe. Without intuitive AI powered tools, most users simply can't unlock its full potential. In the data ingestion phase of our solution, netcdf data is converted into a structured PostgreSQL database, enriching it with metadata. The metadata is then passed through an embedding model, and finally, these embeddings are stored in a vector database such as ChromaDB. The next step is to convert natural language into smart SQL queries. When the users ask queries in natural language, these queries are converted into embeddings and compared against a vector database to fetch the most relevant metadata. The LLM then generates optimized SQL queries to fetch exact results from PostgreSQL. Let's move to the first step of conversation app, that is conversion of netcdf files into relational database. In this we used libraries like Xarray and SQL Alchemy for database connection. By running this program, we see that the storage in PostgreSQL. We converted our netcdf files into two relational database tables like Argo measurements and Argo meta ID. For the verification, we check in PostgreSQL like as shown in the video. We select the first 10 rows from the database to check whether the data is stored or not for all the above columns as it has been showed in the above video. Here is the working code for storing embeddings in a vector DB. In this we generate the summary of each and every profile and convert them into embeddings using transform model. These embeddings are stored in ChromaDB where each entry is linked to the PostgreSQL record. We have the sign up and login options. After logging in, let us ask an example question like what's the salinity data in Arabian Sea March 2024. The LLM then returns an answer which contains the temperature and other salinity data. This data can be compared and can be used for our further proceedings. We can ask another question such as how many unique cycles are present in the dataset. The LLM then analyzes it and answers the question as follows. As we can see, it has answered that there is only one unique cycle present within the dataset that we have currently used for our demo. We have designed our system to maintain the chat history and have also included some starter questions for the people who don't have any idea about the Argo flow data. As you can see, our earlier chats have been saved. These chats can be used in the future. Our LLM also supports the voice input. Now you can see the LLM will be answering one more example question that has been asked. Now let us go to the code to see how our LLM works. In this LLM, we have the database connection for which we have used SQL Alchemy. For RAG pipeline, we have used LangChain approach, and for semantic search, we have used ChromaDB. And using them, we generate queries to retrieve the data from PostgreSQL. The retrieval result is written in form of JSON format, and this JSON output is given as input, that is a prompt to LLM, which converts structured JSON to natural language for users. After chat interface, let us dive into the visualization section. In this visualization section, we have maps, graphs, and table summaries. In the maps, we can see the red dots which represent the Argo float, in which we have longitude, latitude, locations, and profile data. We can plot the graph for depth versus temperature and depth versus pressure for profile 3. And we can see example for profile 3 where the curve shows you the depth versus salinity. And we can also compare the two profiles data. Now let's compare profile 3 and profile 6. We can see the curves depth versus salinity and depth versus pressure. See the difference between the data in different profiles collected by Argo floats. Okay, now let's go to the profile tables. In this, we provide the summaries of the overall profile data collected by Argo float by using the dates range. As you can see on the left side, we have the date section for retrieving the tabular summaries from one date to another date. We also have the download option through which it will directly convert the netcdf data into CSV files and store them into your local storage. We can also download the profile data as a CSV file. Now you can see the downloaded CSV file. So this was about visualization.